Now this is gonna be a hot exercise because I want you to understand how to translate correctly the restrictions that are less than, at least, exactly, at most, and more than. Okay, so the exercise asks me how many English words of length 10 include less than 2 times character A. Less than is this mathematical symbol. So I'm looking for words that these words should have less than 2 times letter A. Let me make here a small matrix to explain this a little better. So here is our first symbol, is less than, and here are the natural numbers, the numbers that are greater than or equal 0, and it goes up to 10 in this exercise. These are the available options that I have, and here he says to me less than 2. So less than 2 excludes 2, so the available options are 0 and 1. And also 1 is allowed. I can't have A 2 times, 3 times, 4 times, or 10 times. So I understand that there are two subproblems that I should solve. One subproblem is these words that have 0 times letter A, and then I want to solve the subproblem that has 1 time letter A. Let's begin with the first one. I have my 10 spots. I shouldn't have an A anywhere, so there are 25 available picks of letter in each spot. So the first part is 25 in the power of 10. Then the second problem is a bit more tricky because I want to have exactly once the character A. Let's see that character A has some options where to be put. It can be put in the first place, it can be put in the second place, in the third place, in the fourth place, etc. until the 10th place. So there are 10 options for putting letter A, and then there are 9 positions left. As I've told you in a previous test, you have to think that we first apply the restriction. So let's say that A took a place of this 10, and then there are 9 spots. This is the rest of the problem. There are 9 spots that can be filled with any of the 25 letters available. So the solution to this problem is 10 ways for the A, and then for the rest of the letters, I have 25 in the power of 9. It's very important to understand this. Let's go to our second problem. I want these words that include at least 2 times character A. At least is this mathematical symbol greater than or equal. So let's go there to fix another row in our array. I can have 2 or 3 or 4 or etc. or 10, and it's not allowed to have 0 or 1. So to solve this problem, I'm going to think with negation, with subtraction, because from all words, this will be all words, I can subtract the opposite of what I'm asked, and here I am asked at least 2. The opposite of at least 2 is less than 2. So all words are 26 in the power of 10, and the opposite of what I'm asked is exactly what I had before, 25 in the power of 10 plus 10 times 25 in the power of 9. Let's go to the next question. Include A exactly once. Exactly means equality, so the only available option is to have exactly 2 A's. I have solved this problem previously, so the solution is 10 times 25 in the power of 9. Next question, include at most 2 times character A. So we have this symbol, less than or equal, and if we fix another row in our table, we have that the variable options are 0 or 1 or 2, and excluded are all of them, 3, 4, 5, up to 10. So I won't use negation here because it's easier to count 0, 1, and 2 than to count 3, 4, up to 10. And here there are 3 cases. One case is that I will have 0 times character A. I have another case that I will have 1 time character A. And finally, I have another case that I will have 2 times the character A. I have solved already the first subproblem with 0 A's. There are 25 in the power of 9 words. and I have solved the second subproblem. There are 10 times 25 in the power of 9 words. Now this one is a bit tricky, and when something is a bit tricky, we've said that the best way to do that, to solve it, is by enumerate the possible solution. Here are my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots, and I'm trying to see how many words are there that there are 2 A's. So let's start counting. Let's say that we have an A in the first position. If the A is in first position, the second A could be in the second spot, the third spot, etc., up to the last spot. So there are exactly 9 solutions. Let's go further. If we have an A in the second position, the second A could be in the third position, the fourth, etc., up to the 10th position. So there are 8 solutions. And you can understand that if I go further, if I put an A in this next position, then the second A can be put in any of the other positions that are right to it. You shouldn't count to put an A, in this case, in the first spot, because you have already counted this in the first case that we were counting. Okay, so if we go further, you can understand that it will go to 6, 5, 4, 3, 2, 1, and all these are different cases of the main problem, so I should add all these things, and the solutions are the sum from 1 to 10, from 1 to 9, and this sum, if we go here for a moment, it didn't fit to the slide very well here, my apologies for that. Calculate by the Gauss's formula the sum from ISON 1 to n equals n times n plus 1 over 2. So the sum from I equals 1 to 9 will be 9 times 10 over 2, and it will be 45. So the solution is actually 45 times, and then we fill the rest spot. The rest of the spots are 8, and I have 25 available options for them. So the solution is 25 in the power of 8. This was, of course, a tricky one. Let's see the final one. Include more than 2 times character A, so I have a greater sign here, and this means that I go strict greater than 2, so all these are forbidden, and I'm going from 3 to 4, etc., up to 10. Again, now you can understand how difficult it would be for me to count all these cases, and negation comes to my mind again. So from all words that are 26 in the power of 10, I'm going to subtract the opposite, and the opposite of more than 2 is at most 2. So the solution to the previous exercise, exactly as it was, goes here. I hope that this exercise helped you understand how we will handle this keyword when we have an exercise like this. And a small typo was made, let me correct it. Here I said 10 times 25 in the power of 10. It's here as exactly it was in the first question.